The comparison between the human brain and the computer is a topic that has fascinated scientists, philosophers, and technologists for decades. Both the brain and the computer are complex systems capable of processing information, solving problems, and performing tasks, but they operate in fundamentally different ways. The question of which one is smarter depends on how we define intelligence and the specific criteria we use to evaluate it. To explore this question, we must examine the strengths and limitations of both the brain and the computer, as well as the ways in which they complement each other in the modern world. The human brain is an extraordinary organ, consisting of approximately 86 billion neurons that are interconnected through trillions of synapses. These neurons communicate with each other through electrical and chemical signals, forming complex networks that enable thought, memory, emotion, and consciousness. The brain is capable of processing vast amounts of information simultaneously, integrating sensory inputs, making decisions, and adapting to new situations with remarkable flexibility. It is also the seat of creativity, intuition, and emotional intelligence, qualities that are difficult to quantify but are essential to human experience. One of the brain's most impressive features is its ability to learn and adapt. Through a process called neuroplasticity, the brain can reorganize itself by forming new neural connections in response to experiences, learning, and environmental changes. This adaptability allows humans to acquire new skills, recover from injuries, and adapt to new challenges. For example, a person who loses their sight may develop enhanced hearing or tactile sensitivity as their brain rewires itself to compensate for the loss of vision. The brain's ability to learn and adapt is one of the key factors that make it uniquely intelligent. In contrast, a computer is a machine designed to process information according to predefined algorithms and instructions. Computers operate using binary code, which consists of ones and zeros, and they perform calculations and logical operations at incredible speeds. Modern computers are capable of performing billions of calculations per second, far surpassing the brain's processing speed in terms of raw computational power. This makes computers highly effective at tasks that require precision, repetition, and large-scale data processing, such as solving complex mathematical equations, analyzing vast datasets, and running simulations. However, computers lack the flexibility and adaptability of the human brain. While they can perform specific tasks with great accuracy and speed, they are limited by their programming and cannot deviate from their instructions without human intervention. For example, a computer can be programmed to play chess at a world-class level, but it cannot spontaneously decide to play a different game or create a new strategy outside its programming. This lack of creativity and intuition is one of the key differences between the brain and the computer. Another important distinction is the way the brain and the computer process information. The brain is a parallel processor, meaning it can handle multiple tasks simultaneously by distributing the workload across different regions. For example, while you are reading this text, your brain is also processing visual information, maintaining balance, regulating your breathing, and performing countless other tasks without conscious effort. In contrast, most computers are serial processors, meaning they perform tasks one at a time in a sequential manner. While modern computers can simulate parallel processing through techniques such as multitasking and multi-core processors, they still lack the brain's ability to seamlessly integrate and prioritize multiple streams of information. When it comes to memory, the brain and the computer also differ significantly. The brain's memory is associative, meaning it stores information in a way that links related concepts and experiences. This allows humans to recall information based on context, emotions, and sensory cues. For example, the smell of a particular food might trigger a memory of a childhood meal, or a song might remind you of a specific event. In contrast, a computer's memory is based on precise storage locations and retrieval mechanisms. While computers can store vast amounts of data and retrieve it with perfect accuracy, they lack the brain's ability to make connections between seemingly unrelated pieces of information. Energy efficiency is another area where the brain outperforms the computer. The human brain consumes about 20 watts of power, roughly equivalent to the energy used by a dim light bulb. Despite this low energy consumption, the brain is capable of performing complex tasks that would require a supercomputer and thousands of watts of power. This remarkable efficiency is due to the brain's ability to process information in a highly optimized and parallel manner. In contrast, even the most advanced computers require significant amounts of energy to perform complex calculations, and they generate heat that must be dissipated to prevent overheating. Despite these differences, computers have certain advantages over the human brain. One of the most significant is their ability to store and process vast amounts of data with perfect accuracy. While the brain is prone to forgetting and distorting information over time, a computer can store data indefinitely and retrieve it without error. This makes computers invaluable for tasks that require precision and reliability, such as financial transactions, scientific research, and data analysis. Computers are also capable of performing repetitive tasks without fatigue, making them ideal for applications such as manufacturing, logistics, and quality control. Another advantage of computers is their scalability. While the human brain is limited by its physical size and biological constraints, computers can be connected to form networks that exponentially increase their processing power. This has led to the development of technologies such as cloud computing, where vast amounts of data can be processed and stored across multiple machines. The scalability of computers has enabled breakthroughs in fields such as artificial intelligence, AI, where machine learning algorithms can analyze massive datasets and identify patterns that would be impossible for a human to detect. Artificial intelligence is one area where the comparison between the brain and the computer becomes particularly interesting. AI systems are designed to mimic certain aspects of human intelligence, such as learning, reasoning, and problem-solving. However, even the most advanced AI systems are still far from matching the brain's overall capabilities. While AI can excel at specific tasks, such as playing chess, recognizing faces, or translating languages, it lacks the general intelligence and adaptability of the human brain. AI systems are also limited by their reliance on data and algorithms, which means they cannot think creatively or understand context in the way humans do. The relationship between the brain and the computer is not one of competition but of complementarity. Each has strengths and weaknesses that make it suited to different tasks. The brain excels at creativity, intuition, and adaptability, while the computer excels at precision, speed, and scalability. By combining the strengths of both, we can achieve remarkable feats that would be impossible for either alone. For example, brain-computer interfaces, BCIs, are being developed to allow direct communication between the brain and computers, enabling new possibilities for medical treatment, communication, and human enhancement. In conclusion, the question of whether the brain or the computer is smarter depends on how we define intelligence and the specific tasks we are considering. The human brain is unparalleled in its ability to think creatively, adapt to new situations, and integrate complex information, while the computer excels at processing data with precision, speed, and scalability. Rather than viewing the brain and the computer as rivals, we should recognize their complementary strengths and explore ways to harness their combined potential. As technology continues to advance, the collaboration between human intelligence and artificial intelligence will undoubtedly lead to new discoveries and innovations that push the boundaries of what is possible.